for a geometric sequence. Here, first of all, geometric sequences are still expressed as a list of terms, but now what happens is that we have a common ratio. And the formula that we're going to use today to find the nth term in a geometric sequence is going to be a sub n equals a sub 1 times r, our common ratio, to the n minus 1. A sub 1 is still our first term, and r is our common ratio, and n is how many terms we're looking for. But let's practice here for a couple of minutes as we flip our paper to the next page. Let's practice identifying our different sequences. Determine whether each sequence is arithmetic, geometric, or neither. Then identify the common difference or the common ratio and find the next term in the sequence. Well, let's just start here. And when we try this here, I'd start with arithmetic. 18 minus 3 equals 15. Does 33 minus 18 equal 15? Or 48 minus 33? Does it equal 15? And they do. And because they do, these values, notice I did the second term minus the first, the third term minus the second, the fourth term minus the third. That means that this is an arithmetic sequence with a common difference of 15. And in order to figure out what our next value is in the sequence, 3 plus 15 is 18. 18 plus 15 is 33. 33 plus 15 is 48. So 48 plus 15, is it 63? Thank you. So we start with that, and that's the way I start all of them. But when we look at this next one here, if we try this, we can try 1/2 minus 1. Don't write this down. And we can try 1/4 minus 1/2. And then we can try 1/8 minus 1/4. But don't write it down. Because when we do 1/2 minus 1, we get negative 1/2. And then when we do 1/4 minus 1/2, we get negative 1/4. They are different, so it's not going to be arithmetic. What I mean by that, the first time when we subtracted, we ended up with negative 1/2. The second time when we subtracted, we ended up with negative 1/4. Those values are different, so it's not arithmetic. So then the question becomes, are they geometric? And so this is the advantage here I can do, is I can erase those values. And what we want to do to determine whether something is geometric is we can do 1/2 divided by 1. And 1/2 divided by 1 is still 1/2. So let's try our 1/4 divided by 1/2 and see what we get. Then we can go back here. And put in a division bar. Does 1/4 divided by 1/2 equal 1/2? Good sign. Let's try 1/8 divided by 1/4. 1/8 divided by 1/4. And sure enough, we get 1/2. And because when we divide every value there, we get a value of 1/2. This means that this one is a geometric sequence. The value of the 1/2 is our common ratio. And what we want to do is we want to figure out, well, what's the next term? Well, we did 1 times 1/2 to get 1/2. 1/2 times 1/2 to get 1/4. 1/4 times 1/2 to get 1/8. To get our next value here, we would take 1/8 and we would multiply it by our common ratio of 1/2. And without typing that in the calculator, just because of time, the answer is 1/16 for our next term. But the key for the rest of the unit is going to be, can we identify whether something's arithmetic or geometric? So that's why we have a couple more. And once again, when we start here, and don't write this down, I'm going to start with 3.6 minus 3. And 4.32 minus 3. And 5.184 minus 3. The second that we get different values when we subtract, that means that it's not arithmetic. So if we do 3.6 minus 3, we get 0.6. But then if we take 4.32 minus 3.6, we get 0.72. So it's not arithmetic. But then we can try our other value here, which is to take these numbers and divide. Let's try 3.6 divided by 3. And we need to try them because the answer could be neither. But we're going to divide. So 3.6 divided by 3 gives us 1.2. 4.32 divided by 3.6 gives us 1.2. So let's try the 5.184 divided by 4.32 gives us 1.2. And we ended up with the same value all 3 times, of the 1.2. And because we went through a division process with that, we're going to get geometric. Our common ratio is 1.2. And we need to find the next term. Well, 3 times 1.2 is 3.6. 3.6 times 1.2 is 4.32. 4.32 times 1.2 is 5.184. So to get our last term here, or the next term, we're going to take 5.184, and we're going to multiply it by 1.2. And we end up with 6.2208. So now the only question is, on part D here, did I give you a neither? And as we look at it, we're still going to start the process the same way that we've done all the other ones. I start and check and see if it's arithmetic. We do that by saying is -6 minus 13 minus a -13. And 1 minus a -6. And 8 minus 1. And 15 minus 8. And even if you don't like negative numbers, if you look down here at the end, 8 minus 1 is 7. And 15 minus 8 is 7. And if you did end up typing these 2 values in, we would still get 7. What kind of sequence has a common difference? and that would be called an arithmetic. Our common difference is 7. And if we want to know what the next term is, we're going to add 7 to 15. So our next term, 15 plus 7, is going to be 22. The key, as we work through the rest of this unit, is going to be able to identify which kind of sequence is it. And the reason is because we're going to have to know which formulas to use. So we identify that it's arithmetic, we use arithmetic formulas. If we identify it's geometric, we're going to use geometric formulas. And as we look at this one here, it says use the nth term formula to find the general rule for generating the nth term of the following sequence. Well, that's our new formula today, which is a sub n equals a sub 1 times r to the n minus 1. So as we take a look at this here, we do notice that negative 6 divided by 3 is negative 2. And 12 divided by negative 6 is negative 2. And negative 24 divided by 12 is negative 2. That makes this sequence here geometric. With a common ratio of negative 2. Well, we also happen to know what a sub 1 is. If our formula over here, we have a sub 1, we have r, and we have n in it. So we know our common ratio. If we look back at our list of terms here, our a sub 1 is 3. And once we identify those values, we can put them back into the formula. So a sub 1 is 3. Our common ratio is negative 2. And then it's n minus 1. That's generating the nth term. Well, we don't know what a term is here. But next what we're going to do is it says, then use this formula to find the 8th term. That means that we're going to take 8 now, and we're going to put it back into our formula where we see n. So our it's going to be first term, negative 2. We filled in the 8 for the n, minus 1. And then we can type that in our calculator. 3 times negative 2 to the 8 minus 1. And that gives us a value of negative 384. So the difference today is different formula. A sub 1 is still the first term. R is a common ratio in this one instead of a common difference. As we look there at the next problem here, I added something in here. It says 2, 6, 18, 54. I said, let's change this problem a little bit, just a little bit. Let's make 2 negative and let's make 18 negative. And we want to figure out the 18th term of this geometric sequence. And just off to the side here, remember that our formula is a sub 1 times r to the n minus 1. And it tells us that's geometric, so we don't have to worry about that part of the problem. Our a sub 1 then is negative 2 because we just changed the problem slightly. All you had to do is put a negative in front of the 2 and negative in front of the 18. Our ratio then is going to be determined by taking 6 divided by -2. Negative 18 divided by 6. 54 divided by -18. But when we divide all those numbers, we end up with -3. It says determine the 18th term of the geometric sequence. That means that n is 18. And now we can go back and fill this in. And I'm going to scoot that over just a little bit here. So what we have -2 times -3, and make sure that you put the -3 in parentheses, to the 18 minus 1. This is going to give us our 18th term. I really should write a sub 18. But when we type it in, we have -2 times -3 to the 18 minus, not plus, minus 1. And we end up with a pretty big number there. Of 258,280,326. And if you think about it, we're multiplying here. Our numbers are going to get big fast. 3 times -2 is -6. -6 times -2 is 12. Sorry, looking at the wrong problem, but yeah, 6 times -3 is -18. 18 times -3 is positive 54. 54 times -3. The numbers get big or small if we're dealing with the negative pretty quick. But what we need to be able to do is we need to be able to identify, is it geometric, is it arithmetic? And as we look at problem number 4, it tells us in the first sentence, the first term of the geometric sequence is 4. That means a sub 1 is 4. The 5th term in here is 9,604. It says find the constant multiplier. We don't know what r is, but we do know one more value. And if I write the equation down, a sub n equals a sub 1 times r to the n minus 1, what other variable do we know? Right? We know it. N. And n is actually in this because we know a sub 5, and it's going to be 5. So we fill these values back into our equation here, and we end up with 9,604 equals 4. We don't know what r is, but we've got 5 terms. And what we need to do is we need to solve this equation. And it's 4 times r to that exponent. So we can divide both sides by 4. And when we divide both sides by 4, we get 24/1 equals r to the 5 minus 1 is 4. I eliminated the parentheses because r is alone now. But what do you think we need to do to figure out what r equals? Well, if we square something, our inverse operation is to square root. So if we raise something to the 4th power, what we have to do to solve this is we have to take the 4th root. And what you need to know is, where is that button on your calculator? And depending on the calculator, It's a math button. The Inspire I probably need to talk to individually, but the math button is where it is. So when we go to our calculator here, what we're going to do is we're going to type in 4, math, and number 5, and then we put our 2401 in there. Let's see, it's the 4th root, 2401, and that's going to give us our value for R. So R equals 7. As we look at number 5, determine the common ratio. Again, the problem is giving us the fact that we're dealing with a geometric. We want to write the nth term formula, but to calculate the ratio, the common ratio, all that we need to do here is we need to take 30 divided by 120, or 7.5 divided by 30, or 1.875 divided by 30. One more time. 1.875 divided by 7.5. And when I look at that here, just 30 divided by this, 7.5 divided by that. Yes, I'm good. If we had the time to type it in, each time, we find out that we get 0.25. And once we know 0.25, it just says write the nth term formula. And again, the nth term formula is a sub 1 times r to the n minus 1. You will be provided the formula on our quiz and test. But when we fill this in, we get 120 times 0.25 to the n minus 1. And that's all we can do on this problem. It just says write the nth term formula. I'm going to try to get problem 6 set up. I don't know that I will get it solved, but I don't want to leave too much extra for us to do tomorrow. Jill accepted a job at a starting salary of $57,000. If she gets a 4.5% raise each year, that means each year she's multiplying her salary by 4.5%. What salary will she earn during the 6th year? So that means that it's a geometric, and our original amount is $57,000. We have a 4.5% in here. How do we write 4.5% as a decimal? Well, remember, 4.5, we're going to move the decimal 1, 2 spaces to the left. So that's going to be 0.045. And when we put this back in there, my R is a little bit misleading, because our formula is a sub 1 times R to the n minus 1. We do know one more thing, and that is that n equals 6. But remember, after she gets the 4.5% raise, then in the 3rd year, you have to look back at the 2nd year salary. So when we fill this in, it's going to be 57,000 times 1 plus 0.045. Because it's increasing each year to the 6 times 1.